The first question wants to imagine to be a person sitting by an electrical wire for some reason that is observing a section of this wire. During a certain amount of time, which is equal to 6 seconds, you measure a certain amount of charge moving from left to right and another amount of charge moving from right to left. In particular, the amount of charge moving from left to right is equal to 4 coulomb, which I'm representing here with 4 little balls, left to right. But at the same time, you also measure an amount of charge equal to 7 coulomb that is moving from right to left. The problem wants you now to calculate the amount of current in amps given the delta time and given the amount of charge that moved through the wire. Solving the problem simply requires the knowledge of the definition of a current, that is defined as delta Q over delta T. Which this equation simply states that the current is defined as the rate of charge moving through a wire, or the number of charge that you observe during a certain amount of time, divided the amount of time. Now, for this problem, delta T is easy to calculate because it's 6 seconds. It's actually defined by the problem. Delta Q is a little bit more complicated. However, if you recall the definition, the correct definition of a current, delta Q is in effect the net amount of charge that is passing through the section of a wire. So in this case, because we have 4 coulomb moving from left to right and 7 coulomb moving from right to left, we can say that the net amount of charge moving through the wire is an amount of charge equal to 3 coulomb moving from right to left. So we could cancel this and we could say that the net amount of charge is simply equivalent to 3 coulomb moving from right to left. So now we know what is the delta Q that we have to use to solve this little equation. This is 3 coulomb. Now we can very easily solve this little equation. So I will be equal to 3 divided by 6, which is equal to 0.5 amp, or 500 milliamp.